And I actually got ahead of myself. Let's go back up and do an example first before we talk about existence of a double integral. Okay, so here's a certain function over a certain region, and it says find the Riemann sum using a partition of 4 equal pieces and midpoints as test points. So this is very helpful. To begin this, I kind of need to visualize where I'm going to go. So I know I need to produce a Riemann sum, right? So that in the last video we said it's going to be the height of the function at our certain test point, so that's going to be our midpoint, and then we also need to figure out kind of the area of that face of that prism. So that's going to be useful for us too. How I begin this is I kind of draw a little sketch of the region. Okay, so if I draw a little sketch of the region, okay, it's a square, and I'm going to divide that into 4 equal pieces. Okay, that actually ends up being pretty nice. Divide each of these in half. So this is the region for x. I know it goes from 0 to 2 pi, and similarly for y, 0 to 2 pi, and so this boundary in the middle here would be pi. Okay, so then if I use midpoints as test points, okay, I can draw them here. Okay, and so the midpoints would lie precisely at, excuse me, pi over 2 and 3 pi over 2, and just combinations of those thereof. Okay, so to find the Riemann sum here, okay, so Riemann sum is equal to, okay, by definition, it is I and j is equal to 1 to n of f of Cij, and then delta x, delta y. Okay, well, delta x and delta y, I think those are the same for each of these, right? Delta x is the width of each interval. Okay, so if I look at delta x, that's going to just be pi, and similarly delta y is also going to be pi. Okay, so that's pretty nice. Okay, so then all I need to do is add up. So this is going to be pi square. Then I need to just add up all the midpoints. So this will be f of C11 plus f of C12, I'll explain the notations in a moment, and then plus f of C21, try that again, C21, and then plus f of C22. Okay, and so I'm identifying this as f, or this is the point C11, C12, C21, C22. Okay, okay, and when I do this, okay, so I would need to put in, so this is pi by 2, comma pi by 2, okay, and so if I put that into my function, well, pi over 2 for cosine is 0, so that's first part's going to be 0. Okay, so I'm just going to begin the evaluation here. Pi square, and then 0, and then plus f of 1, 2. So this is still, so 3 pi over 2 for x makes sine 0. No, 3 pi over 2, that's negative 1. And then cosine of pi over 2 is still 0. So this is 0. And then for all of these, we're going to end up getting 0. Okay, so this time we're just going to get 0. Alright, so just a quick example of how to use the Riemann sum method to approximate the volume. And again, in your homework, you might have a few instances where you might need to approximate using Riemann sums. And so generally, we will tell you which points to use, if you should use midpoints, or you might be asked to use points in the upper left or points in the lower right. And so for a particular box or for a particular region, and so just make sure to follow the instructions on whichever ones we say to use. Alright, and that's going to be the end of this approximation video, and so next we'll talk about the existence of these double integrals.